Alright, we're now looking at target 1.2. Our master learning objective is I can use proportions to identify similar polygons. So using proportions, just like we did in our last one, but now really what we're focusing on is identifying similar polygons. So, what are similar polygons? Similar polygons are shapes, really. A polygon is just a shape with some number of sides. So like a triangle is a specific polygon with 3 sides. Octagon is a specific figure, right, shape with 8 sides. So poly just means many. So similar polygons are shapes that have congruent, that's supposed to be an R, and the symbol for congruent is that, congruent angles, and proportional sides. So their sides don't have to be equal, they have to be proportional. Okay? So if we look at this lovely picture here, I can tell all the angles are congruent. These markings, right, this one has 1 and this one has 1. That tells me that these angles are the same. They're congruent. This one has 2 and this one has 2. Again, that having the same number of markings is telling me that angle B is congruent to angle X. Angle C is congruent to angle Y. And angle D is congruent to angle Z. So this is, right, all my angles here are congruent. There's 4 angles and I have 4 sets of angles congruent. The other thing is that the corresponding sides have to be proportional. So if you look at all of these from 15 to 5, right, this one is 3 times bigger than this one. This one is 3 times bigger than this one. This one is 3 times bigger than this one. And this one is 3 times bigger than this one. Every side is 3 times bigger. They all have that same ratio. So that's what similar figures are. So let's look at example 1. If triangle FGH is similar to triangle JKL, list all pairs of congruent angles and write a proportion that relates the corresponding sides. Alright. So let's find our congruent angles first. So, if you notice, in the example we looked up at here, these shapes were in the same, what we call orientation. Right, A and W, they're both in the upper left corner, and those are the congruent angles. That's not always going to be true. Okay, so like in this example, these triangles are not in the same orientation. So we need to be very careful about how we choose our angles. Sometimes it's easier than other times. Like these triangles are somewhat easy to see which ones go together. But the biggest thing we can do is look at the names of the triangles. So this triangle, its name is triangle FGH. We name triangles using their points. This triangle is triangle JKL. When you're writing what this is called a similarity statement. When you're writing a similarity statement, you have to go in the correct order. So when it gives you a similarity statement, you can use that to know what the correct order is. So for example, I know angle F is congruent to angle J because they're both in the first position of my similarity statement. Okay? So we'll write that. Angle F is congruent to angle J. Same thing. I know G is congruent to K. I've already used a 1 tick mark, so I'm going to use a 2 tick mark. And again, I know that because they're in the same place in the similarity statement, in the name. Angle G is congruent to angle K. And finally, H is congruent to L. And now I'm going to use 3 tick marks. Right, and this is just an angle symbol. We'll put it before all of our angles. If you just write F with no angle symbol, that's like this point F, not angle F. And that angle is that space between the two lines. Okay, how much the line has rotated. So we list all our congruent angles, and now we have to write our proportional sides. And we're going to do the same idea here, where we look at the name. So we said F and J are congruent, and then G and K. So I'm going to go from F to G, and then in the other triangle, I'll go from J to K, right? So F to G is this line here. That's my one side. And then J to K is my other side. So this is the distance from F to G and the distance from J to K. That's going to be one ratio, and that's going to be equal to, I'm going to do the same thing, right? G to H. Right? Or you could look at what you just did. I'm going from my 2 lines to my 3 lines, and then K to L. Again, going from my 2 lines to my 3 lines. It's that line. So you have to be very careful how we're writing these. And then last, H to F, and L to J. Right? Or 3 lines to 1 line, 3 lines to 1 line. Right? So I'm going between the 2 congruent angles. So it's a matching game for writing those. So those are our congruent angles, and then our proportional sides. All right, looking at factor, the scale factor is the ratio of the lengths of the corresponding sides. Okay, so if you do what we did up here, where you set all these ratios up, right, whatever this simplified to, that would be your scale factor. It's not going to be super important right now, but when we do scale factor, we do the new over the old, and that's really going to come in when we do dilations and are finding the scale factor from our first image, or what we call our pre-image, to after we dilate it. Right now, it doesn't really matter which one you choose as your new and your old, as long as you kind of keep it the same. I'll usually say like old, new, right? Like how you would read left to right. So in this case, my new is this 3, and my old is the 6. So my scale factor is 1/2. Okay, so it's whatever that, right? If I start here, this triangle is going to be half as big. Okay, I scaled it down by 1/2. All right, looking at our example 2, this is our last example. Determine whether the 2 triangles are similar. So again, I should have all my angles congruent, and I should have all my sides proportional. That's all we know right now. We're using the definition to determine whether they are congruent. And so I need to see if I have any corresponding angles, or congruent angles. So A is 117 degrees, and H is 117 degrees. That means those are the same. Forgot my squiggly. B is 27 degrees. I do have a 27-degree angle here in F. Ooh. Sorry, don't need that. So those are congruent. And then angle C is 36 degrees and angle J is 36 degrees. So again, those are congruent. Great, I have all my angles congruent. I now need to show that my sides are proportional. So I'm going to set up new over old for all of them. So I'm going to choose the 6 first. This is my largest side, so it should match up with the largest number on this triangle too. It's also between the blue and the green, and between the blue and the green. So you can kind of think about it that way as well. So I'm going to do 6 over 12. That should equal, let's go here, I'm going to cross 6. Well, 6 is my smallest number out of all 3 of these, and my smallest number. All right, so those are my matching. New over old, so 3 over 6. And then we have our remaining numbers 4 and 8. And when I simplify these, I have 1/2, 1/2, and 1/2. Right? My fractions are all the same. Great. One thing to note, if you look at these numbers on top, these are all from the same triangle. And if you look at the numbers on bottom, those are all from the same triangle. Okay, so when you're setting up these proportions, you have to be very careful, because if you flip this, if you said, oh, 8 over 4, you'd get 2 here, and then it would look like they're not the same. Okay, so make sure that the numbers on the top are all from the same triangle, and the numbers from the bottom are all from the same triangle. Now, here we can say that, yes, and then we're going to write our similarity statement. Sorry that it jumped. Stay. Hold on. Hopefully it will stay. But now we're going to write our similarity statement. So I'm going to go with triangle A, B, C, right? A, B, C. Similar only has one little squiggle. And then I'm going to go in the same order, H, F, J. Okay, so be very careful with how that is. So yes, they're similar because all angles are congruent and all sides are proportional. Okay. All right, and that is it for our 1.2 video. I'll see you guys tomorrow.